Hi, everyone, and welcome to our fourth annual IDWSDS. This year's theme is Thriving Your Environment. We are recording the event, and videos will be available on the Caucus for Women in Statistics and Data Science YouTube channel. We kindly ask you to post your questions to the speakers in the Q&A chat. Without further ado, I'm delighted to host this session, 401, Advanced Prompting Techniques for Data Science Workflows. And Jeanne McClure is our speaker. No, I did not share my screen, but you can go ahead and share yours.
Okay. Hi, everybody. I am Jeanne McClure. I am a postdoctoral fellow with the Data Science and AI Academy at North Carolina State University, where my research focuses on data science and higher education and using our ADAPT model. Also, I do AI enablement across the campus and beyond. This is really an extension of what I developed from my dissertation in 2022. It started, I was trying to develop a traditional machine learning model, and lo and behold, thank goodness LLMs came out because my data was very deficit and I was unable to create a machine learning model. But today's session, Advanced Prompting Techniques for Data Science Workflows, really I'm really honored to be here and be invited by the International Day of Women's Statistics and Data Science. And this work is supported by the NSF grant, but the opinions and any information shared by me is my own and not represented the views of NSF or of NC State's Data Science and AI Academy. All right, so what are we going to do today? So this is a 45-minute, super fast. Put Q&As in the session, and I will share slides in a little bit so that you can follow the demos. Usually I do this in a 120-minute hands-on, lots of reflection and talking. So this is new for me to do it in a webinar, so please bear with me. I will be toggling through different screens in a little bit, but we will first ground ourselves in responsible AI and governance. Really, this is the ethical layer that underpins all of our data work. Then we'll unpack some prompting framework that I developed, which is called the ICI. We'll walk through that a little bit more in a little bit. We'll look at key prompting types. I'm sure a lot of you have heard about them and also dabbled with using them. Zero shot, few shot, chain of thought, role-based. And finally, we'll demo some examples. I'm going to demo today in Poe, Groq, Groq with a Q, not with a K. The one with the K is the one that's owned by Elon Musk, but we're going to use a different one, Ollama, which is on our desktop, and I will share links that you can download it later. And then we'll peek into some natural language use for Colab with the IDE and inlay. And also we'll look at a quick video if there's time for positron. Again, you'll have these slides so you can refer back to the notebooks and any of the demos. But before we dive into those tools and code, let's ground ourselves in what really matters, responsibility. So as statisticians and data scientists, we're not just running analysis, we are really stewards of evidence. The choices we make, how we collect, clean, and interpret data really directly shape the decisions that affect lives, policy, and trust in science. Responsible AI means using these new models to augment our reasoning, not automate our judgment. Large language models can help us debug, summarize, or visualize, but they can't really shoulder accountability. That really remains on us. And data governance is the scaffolding that keeps our work credible. Even if you're a solo practitioner, you're bound by the same professional principles to protect privacy, respect consent, verify sources, and document every transformation. Around the world, this expectation is now codified. We have the EU AI Act, the US Executive Order on AI, and the Council of Europe AI Treaty. And they all call for systems that are transparent, auditable, and fair. And that means for us, because those words, transparency, audibility, fairness, are really the backbone of statistical integrity. And they're the same ideals behind responsible research and ethical data use. So when we write our prompts or build a pipeline, we're not just optimizing a model, we're building trust. Responsible AI begins with responsible data, and that's what turns technical skills into professional integrity. And maybe that's the real question for us all. In an era accelerating AI, how do we keep integrity advancing just as fast? So what we really need to do is we need to kind of look at the AI landscape. And this probably really has changed too. I developed this little graphic last year in the spring, but as we know, everything is changing so fast. But let's zoom out for a moment and orient ourselves in this enormous AI ecosystem. At the widest level is really this AI, artificial intelligence. It's really been around since the 1950s, and everything from recommendation systems to driving self cars. Inside that sits machine learning, ML, and that's where systems learn patterns directly from data. And a lot of us have been using this type of traditional AI for a while now, and even with our natural language processing and NLP. And so we can even go one layer deeper and look at deep learning, where neural networks begin to recognize images, sound, and language. And did you know that in the 1940s was really when the first neural network or node was created, which is really fascinating to me. But going back to the NLP, really that branch that lets computers understand and generate human knowledge. And that's really the heart of what sits for what we'll be talking about today, which is LLMs, or large language models. But then, of course, we have generative AI, which includes text, images, and videos. It's the umbrella of over all of this. And just beyond LLMs is the next wave, this agentic AI, which can plan, reason, execute autonomously. But today, again, our focus is really on the LLMs, learning how to make them behave more intelligently through structured prompting. And if it feels like these models are appearing faster than we can keep track of, you are right. The model space has exploded from just a handful in 2023 to dozens now, each built for slightly different purposes. And open source models like Llama, Mistral, and DeepSeek, which are part of the Ollama ecosystem, give us transparency and local control. And these are perfect for when privacy, reproducibility, or compliance matter most, because you can put them on-prem or on your local drive. And then there are the closed source models such as GPT-4, Claude, and Gemini, which we're all really familiar with. Those bring highly aligned reasoning and multimodal capabilities where they can do natural language processing and visual. But they live in the cloud and come with usage limits and, of course, costs. And then we have these multi-model platforms like Poe and Groq, where we can test side by side of these different models and actually compare reasoning styles. And then in daily practice, most of us move fluidly between these worlds, open for transparency, closed for capability. The real skill is matching your tool to your data sensitivity, compute power, and workflow needs. And because a prompt never lives in isolation, it really interacts with the model's architecture, its context window, and its guardrails. All right, so let's think about some of these AI assistants that I just mentioned. So we have our chat interface conversationals. And so this is like Claude, ChatGPT, Gemini. And Claude is our reasoning partner. It's really great for debugging, handling long documents, or doing multi-file logic. ChatGPT is our generalist. It's strong at structured discussions, coding, and general visualized explanations. And Gemini, I said Gemini, not ChatGPT. Gemini is really our bridge to bring multimodality. It's combining text, image, and data inside Google Colab. And then we have Mistral and Llama, which fit into this chat interface, which is conversational. But then we also have where we can take Gemini and we put it in Colab. It's automatically there. You don't have to run it through an API or anything. There are some limitations depending on what Google workspace you have, whether it is pro, whether it's educational, what the education system offers to its faculty or students if you're working in that type of industry. Also, now we have Positron, and Positron has a Positron Assistant, and you can actually upload or through the API connect this IDE integrated assistant with Olama or even Anthropic's Claude. All right, so what are some of the fundamentals of prompt engineering before we go in and we start doing some prompting? We have zero shot, and zero shot really is, and probably a lot of you have already seen this, but for those that maybe haven't or don't know what these are, I'm just going to give a really quick overview. So we have zero shot, which is really one clear instruction. So when you're doing your prompting, you're just saying one thing, do this, and that's it. But then few shot is really where you're giving multiple examples to anchor its behavior. For chain of thought, reasoning is key here. And reasoning really is asking for steps, and it breaks complex problems into these logical steps. And then we have role-based, and that's where we're really adding like this dimension, and you don't always have to use it, but it does seem to help from what the research is showing us. And it defines the perspective. It's a persona, it gives it audience. And finally, just real quick, we have temperature. We're not going to be doing any temperature today, but if you use the API, and some of the sandboxes do allow you to do this when you have more of the paid. And so like a low temperature makes the AI responses more deterministic, where a higher temperature would increase randomness, really creating a more creative or diverse output of what you would get from the model. And then, of course, almost every organization has some type of prompt engineering book that you can look at. And what we're seeing is that they do have a lot of similarities. The thing that I found was interesting is for Microsoft, for their Copilot, and Copilot actually has a whole ecosystem of Copilots. So where I thought there was just one Copilot at one time, but there's actually multiple, and they are in different ecosystems, depending on if you're using the Office or if you're using Azure or Copilot Studio. And so what's interesting with that is it uses more of markup language in the prompt, but we're not going to be doing any of that today. But again, many organizations offer these guidance, but they really all emphasize clarity, context, and iteration. And so I developed this ICI framework when I was doing my dissertation. And really what I noticed is it's the bare bones of a lot of these. And so if you look at it, for me, it's just a simplified kind of framework. And so I've used it for since 2022 and kind of updated it here and there, of course. And it seems to work in almost all the models that I've done, except for ChatGPT-5. I get mixed results, but that's because we know that ChatGPT-5 is bringing in different models. We don't know which one it's actually using. So I tend to click down and use ChatGPT 4.0 so that I know what I'm using when I'm in there. But instruction, it has three different elements: instruction, context, and input. And instruction is really what the model should do. And so here we can see I'm telling the model to generate a regression summary table comparing model A versus model B. The context is the why and the for whom. So using anonymized survey data and robust standards, we could also put the persona here as well. And then input, specify data and parameters, any variables, file paths, or prior outputs. And then even to overlay, what I add there is like really focusing on these linguistic lenses. So we have syntactic principles, and this is how you phrase the command using like imperative verbs analyze, compare, visualize, etc. And then we have, of course, semantic principles. And semantic principles are really where you're using the precision language. So we would use data science terminology, statistical terminology, natural language terminology, etc. Whatever the meaning is behind your prompt. You want to be very explicit. Remember, this is a machine. It's not your friend, so it can't infer what we're trying to say. All right, so I also am going to minimize my screen here so that I can put this into the chat. These are the slides, but also I'm going to be doing demos. So if you want to go ahead and do them with me, you'll have them. But if you want to do them later, you can do them later. But it's in the chat there so that all of you can go ahead and grab it. Go ahead and open that up. All right. So what we're going to be doing is I'm going to show you the difference between an unstructured prompt and then a structured prompt of what I developed using the ICI framework. And we're going to kind of walk through this and look at what's happening under the hood. I already have Poe opened, and because of time here, I want to make sure that I am moving quickly, that we can get to almost everything. What you see is this is Poe, and Poe actually has a bunch of different bots. I clicked on the left-hand side of where the bots are, and I'm using just here the regular assistant, but you can see that you can put in different bots if you wanted to, and you can actually compare them side by side. So here I'm just analyzing a basic classical business analytics challenge, understanding customer churn. The prompt that I'm putting in is this prompt right here, and I'm analyzing customer churn data with features including subscription length, monthly spending, and customer demographics. What visualizations would best help me understand patterns in this data? And please explain why each visualization is important. Maybe we would put that last line in there. Maybe we wouldn't. I put it in there. And so the goal here is really for us to see, like, what is it going to put out? Is it going to be very similar or not very similar? So as we run it, the unstructured prompt, what you can see, and feel free to run this in your own. I don't know that you have to sign up or not. I can't remember. It's been a while. But here, what we get back, the model is listing a variety of charts here, histograms, box plots, scatter plots, heat maps. Oops, I don't know what that is there. Okay, heat maps, and we can see that it has maybe some survival curves, a cohort analysis, etc. So it's giving like pretty good one-line explanations. It's not that bad, of course. But what we don't see is that there's no instruction. It doesn't say how I wanted the reasoning structured or how many visuals to include. It doesn't know the business size, the churn rate, or the specific goal behind the analysis. And the input is vague. Understanding, this is the original prompt, so understanding patterns could mean anything from descriptive to predictive, right? And we're professionals, so we're able to actually add this. If you're newer to the scene, you might not know this, so this might be fine for you. But then we can go ahead and we can add the more, the structured prompt with the ICI framework. And so I'm just going to grab that and I'm going to put it in. Okay, and you can see that it's moving and it's starting to give like very similar, except for that now what we're seeing is that the model focuses on 4 really well chosen visualizations to talk about: a cohort analysis, box plot, bar chart, and also maybe a heat map estimation. So for each of them, it explains why it matters and what insight it could reveal. For example, that short-term subscribers or low spenders are driving the churn rate, the churn spike. That's not a list, that's really a reasoned analysis. Because we gave the model this structure, and I'll show you on the next slide. So if you see, because we gave it the structure, we did this instruction, we did context. And you'll see that even though my prompt was written differently when we first wrote it, it still has all of these elements. So don't feel that you have to write the prompt exactly like ICI. It can be moved around a little bit. What's important is that you have these types of features there. Okay. So again, what does this tell us? This really just tells us that instruction tells the model how to respond, how many visuals, how to explain it, and what depth to include. Context tells it why the task matters, the company data set, the rising churn rate, and we anchor the responsible in a business goal. Input clarifies exactly what to produce, and that's here. And so that's giving actionable visualizations that explain that churn drivers. And together it really turns this descriptive response into structured reasoning, aligning with professional workflow. So it's really like passing parameters to a function. All right, so that was Poe. And now what I'm going to do is I'm going to show you Groq. And Groq also, this is just a very classic missing values, one that we all have. And so Groq, when you click on it, you have to click the Get Started. And once you get in the Get Started, you're going to click on Playground. And this is more of like a freemium. And you can, of course, change the models here on the side. As similar before. Also, if you wanted to write it here and then pull it into, pull the client through an API, you're able to do that as well. Later on, I'm just going to move this over a little bit because we're not going to do that, but you can notice in your own that it will start changing. So I'm just going to grab this unstructured prompt. So again, we can compare what we're seeing, the difference, because we want to know like what is the difference between unstructured and structured, because a lot of times I think what we think is, oh, that was just fine. All right, and so we're going to submit it. All right, so what are we seeing here? This looks pretty good, right? Let's see. So we were asking, it's giving us a lot of code snippets. I have a data set, and you might see when you would use different models, and you're welcome to play with this, of course, that it would give you different results. But what we're seeing here is that I have a data set with missing values in several columns. What are the best approaches to handle this in Python? And so our prompt is giving it, it's not agentic here. It is, we are just giving the prompt way for it to kind of pull the information. So it is telling us that, let me look and see what I have tagged here to look at. One that we didn't specify, so it lists, yeah, general. Here we have a list of general information of what to use. So we can either diagnose the missingness, decide on imputation strategy, practice code snippets. It's giving different things, whether or not we wanted to do it with machine learning or not, quick checks. So it's giving us a lot of information. But the problem here is that we didn't specify the format or the depth of it in explanation that we wanted. The model doesn't know what kind of data we're dealing with or why it matters. And also the input is very vague. A data set with missing values could describe anything from sales to sensor data. But it does give pretty good information to go ahead and start. But then if we go ahead and we take this more structured prompt and we put that in, and this one is a data science preparing a healthcare data set with 10,000 patient records for machine learning. I have missing values, and the missing values are here shown as a percentage, 25% for age, 15% for blood pressure, and 10% for diagnosis fields. Provide specific code examples for handling missing data in numeric, categorical, and time series variables. Explain the best approaches to handle this missing data in Python. All right, so now the difference is immediate. Like, we're really getting more specified information here. I'm just scrolling up real quick. Okay, yep, right there. All right, so it's now going to give us a quick reality check. It's breaking, it separates numerical, categorical, and time series strategies. It shows specific code examples using simple imputer, next neighbor imputer, also iterative imputer in Python. You could also ask it to do this in R for tidyverse if you wanted to. It's also giving us specific variables that we might be using. It adds a pipeline example for reproducibility and data leakage prevention, and it even explains why certain imputers are better for specific missing data patterns. And here's the full pipeline, putting it together, how to evaluate the imputation. So it's not any longer just information, that's reasoning in context. The model's now behaving like a colleague walking through a data cleaning plan. So what's really happening here is the structured prompt is giving Groq enough parameters to simulate a step-by-step plan. And it looks like it's deciding how to proceed, running diagnostics, comparing options, even suggesting validation steps. But that's not agency, it's just structure. Groq isn't planning autonomously or looping through multiple states. It's completing a reasoning chain we initiated with our prompt. The same thing in the first prompt as well. In other words, it's not acting as an agent. I just wanted to point that out because I did have somebody in a different workshop that was asking about it. So it's executing an inference pathway. Yeah, so that's just one more. And then also I am going to show you, so that was Groq. And the next one, oh, well, let me show you, like, this is the breakdown. The instruction, we have the instruction broken down. We have the context broken down. Again, I don't have this in a linear fashion, but I do include them all. And then the input here is the question that we're kind of asking. All right, so finally, I have Ollama on my desktop, and it is on my local machine. And so now Ollama, you don't have to run it in the terminal. It actually has a chat that you can use. And I have already ran this just for time because I want to get to the Colab and also hopefully have time to play the posit information. And so the last one is Ollama Chat. If you want to download Ollama Chat, here is the link to do that. And of course, we have an unstructured prompt and we have a structured prompt. This is a little bit more, it has steps and also it has reasoning. And we'll see. So we're going to suggest 3 ways to visualize the relationship with customer age, purchase amount, and frequency of purchases. This is a customer visualization analysis. And I hope you all can see this. I think that you should be able to. So this is Ollama. And Ollama, again, this is not in the cloud. This is on my local machine. And you'll see down here in the chat where you can add your prompt, you'll see that you can pick different models and you'll see some that are downloaded. Every model you download takes up space on your local machine. So just please remember that. And then of course, there's ones that go to the cloud. A lot of people like the Gemma, and that one can do multimodal analysis or prompting. And then also this vision one is supposed to be really good, but the most general purpose one is this Llama 3.1. And you'll see I had already added this basic unstructured prompt here, and it's doing a pretty good job giving us some information about how to discuss It's a decent start, right? So here it's telling us about a scatter plot, a heat map, and also an interactive bar chart. And each comes with a short description like use color coding for purchase frequency or let users filter by segment. But here's the catch. The model doesn't know who the visualization is for or what decisions we're supporting. It's very generic, and that might be fine for some contexts. Again, we're showing a more advanced prompting style to help be efficient in your workflows. But think of this as your textbook prompt. It's clear enough to get a list, but it's not enough to drive insight. All right. So then we're going to put in the more using the ICI framework. And so this is an e-commerce data analyst for an online clothing retailer. I'm trying to understand purchase patterns across different customer age groups. I have a data set with 100,000 transactions containing customer age by 18 to 75. Purchase amounts 15 to 500 and frequency of purchases 1 to 30 purchases per year. The marketing team needs insights for targeting different age demographics and personalized promotions. Suggest 3 specific ways to visualize the relationship between customer age, purchase amount, and frequency of purchases. For each visualization, explain how to implement it, what patterns it might reveal, how the marketing team could use the insights. And I don't know if you noticed, but we are using a chain of thought here because we're asking it to do some step-by-step reasoning. All right, so what we're seeing here is really immediately the tone changes. So we have a box plot for how spending might be varied by age group. We also have a scatter plot with a regression line that might reveal correlation trends. And then we have a tree map that might visualize demographic, share, and purchase intensity. So, and look what it adds, not just what to do or what you might find, but why it matters and how the marketing team might act on it. So for instance, if you read this closer, you might notice that it would say younger customers with lower order values might respond to bundling offers, while middle-aged groups with higher purchases amounts could be targeted with loyalty rewards. So it does give us some insight quickly if we need to have it. So again, what changed? We gave the model context. We gave the model context. We gave the model a role, the e-commerce analyst. We gave it data set, size, variables, and audience. We gave it instructional scaffolding to explain and implement patterns and applications. And so across all of those demos, which are really those conversational agents, when we are working with the chat interface models, and whether we're handling missing data or comparing algorithms for imbalanced data sets or creating customer visualization, we really know that we can use like this pattern, instruction, context, and input where we're telling the model what format and depth you need. We give it domain knowledge, role, purpose, and define a specific task. And you'll see in most of the other prompt engineering books, that's what it's all about, being clear and precise when you're giving a prompt. All right, so now what we're going to move on to is the Colab notebook. And so when you go to the Colab notebook, it'll open up, and just in case people came in late, I'm just going to quickly share this again, the slides. And you can find all the information on the slides here. There you go. All right, so is nobody seeing my screen? Is that what I'm seeing? Okay, awesome. Sorry, I was just checking the Q&A to see if I needed to answer anything. All right, so again, those are the slides. We're going to be going into a Colab notebook. And this notebook kind of walks you through. Now, this is a little different than the ICI framework. Again, when you go into the participant one, you won't be able to change this until you make a copy. So you're going to make a copy and save it in your drive, and that will create your own copy. And that's the one that you can go ahead and you can mark up. I'm going to use the instructor one that I created. And so this is just a way to show you about how Gemini is already in a Colab notebook. And then we're going to look at Positron real quick. I think we'll have time to do all this. All right. So the first thing is that when we're looking at Gemini, and so here we're going to be looking at bird migration data set. And so I'm kind of going through this quick, but you're welcome to go back. I have it narrated that you should be able to follow. When you see the code chunk in Colab, if this is your first time looking at a Colab notebook, you can do R or Python in here. I'm just doing Python for this particular one because R is kind of tricky when you try to do maps, and I wanted to do a map for this. But you can do the same thing in RStudio or in Positron. Not all of this, just the end part. I'll show you when we get there. But when you're in here, Gemini is already embedded in the notebook. And so when you're looking at the code chunk, it says start coding or generate with AI. When you click on generate with AI, it's going to bring up a new chatbot. It used to be above, but now it has like a chatbot that comes up on its own. So I'm going to go ahead and I'm going to put in, copy and paste the following prompt, write a simple Python code to read in a URL and save as DF for data frame. I don't need to write that. It knows that already. And you'll see below that I have the URL. And so we will have to copy the URL if we accept the code. All right, so up above, what we see has happened is that it's now giving us code, and also it's giving us comments so that we don't actually have to add those at either. We might want to update them. And so we can decide to accept and run or accept. I'm going to accept it. And it looks like it already put in the URL. Yesterday, when I reran this, it did not put the URL. It said to paste the URL. So if you're doing this on your own, it might show that you have to copy and paste that URL. And so that's just the URL down here, and that'll take you to the bird migration data set. All right, I'm going to run it by clicking on the little run button. And you can see that it's importing pandas as a PD. And then I have the URL, and then I'm saving it as a data frame, and I'm using the PD, but we don't see anything. So of course we would have to go ahead and run DF. And so there it is, the data frame. Yep. And so I can go ahead and run that, and then it'll show your data frame. There we have it. You could also do data frame head if you wanted to. If you didn't have time, you can go ahead and run it down below. It should also have it. If it doesn't have import pandas at PD, you might have to run that if you didn't run that already. All right, so now what we can do is we can quickly ask it to, so we could understand our data. I just on the time, because I have about 5 minutes left and I want to get to the last part. I don't know that we're going to get to Positron, but the video is in there if you want to watch it, because it's almost 12:10 and I only am till 12:15. But you can go ahead and run this prompt. I was asking for you to put in a prompt to see like how you could get it. Here below is where I have the prompt if you want to generate it and try to get it, but this is what it should bring up, is the print DF columns to list. And you can see, oh, here I have all of the columns. Why this might be important is that you want to create one comprehensive prompt. And so using the ICI and also mashing it with ChatGPT or Gemini, the conversational agent, or even Olama. And so what we're seeing down here is that we can do that. And I use the ICI and I created a workflow prompt, a comprehensive prompt, where I put this prompt into ChatGPT. You don't need to insert the URL here. You can just say insert URL and then change it in the code when it gives you back the code. If you copy all of this, I need to analyze bird migration data, install only Folium with a quiet flag, import pandas, NumPy, these are all of the packages that I want, load the data from the URL, and I want to print data set shape. I want to know the first 5 rows. I want to print the column names, print data types, print summary statistics, print missing values. If you use ChatGPT 5 for this, it might stop at the map. And that's, again, I would use ChatGPT 4.0 if you're going to do this, but that's the entire prompt. And I have a space down below for you to put it in for ChatGPT. I've already done it with Claude, and I'm going to run it real quick. So you can see when I ran it in Claude, this was the code that it outputted for me. The only thing I had to add was the URL, and that's just because I didn't want a lot of information. I didn't want to confuse the model by giving it a URL. I just wanted it to have a space where I could put the URL. And so it gave me all of this information. This was all the code that I got back from Claude. And let's see what the output it gave me. So it's giving me a map. It's giving me all of the information. So basically I just did exploratory data analysis. Now the prompt does take a little bit of time, but once you have a flow, you'll be able to do it very carefully, and quickly, I should say. And so here's the information. Here is the flight patterns, longitude and latitude. Here's an altitude distribution chart, an altitude by bird type. Speed distribution, speed by bird type. Here's a correlation heat map. And so, yeah, so that is the ICI framework that I'm using. And that is the notebooks. Again, I have a video in here if you want to watch it about how positron is connected with either Anthropic or Olama. It does very similar stuff, except for it has a chatbot on the left-hand side now, and you can use that as well. That's the positron assistant, and it's only in positron. Here's some resources if you want. There's a demo day on October 29th for Posit. I don't work for Posit, but I do love them. I love R. I know it looks like I love Python, but I do love R too. I'm R first. And here's exploratory data analysis with positron. This is really good by Mina. And then
somebody asked if you could drop the Google Colab link. Do you have that easily?
It's in the slides.
Okay.
They just need to go to the slides and grab it. So it has all the demos. Again, if you go to the slides link, it has all, this is all the slides with the link for the Colab notebook.
You're amazing. Sorry.
Yeah, no. Yeah. And I have other notebooks. So if you're ever interested in more stuff for data science, please feel free to reach out to me. My information is on the last slide.
100%. Thank you so much. I think we only have 1 minute, so we probably don't have time for question and answers. But I will pass the message along that's in our Q&A.
Yeah, and sure, if anybody has anything, please reach out to me directly. My email's on there.
Awesome. Thank you so much.